Hi everyone, thank you so much for attending this talk. So today I want to discuss about how open source powers the modern data stack. But first a little bit about myself. So I'm Michel Tricot. I've been working in data for the past 15 years. I've been working with petabyte scale, Hadoop cluster, and over the past few years I've been working a lot with BigQuery, Redshift, and most recently Snowflake. And today I'm the co-founder and CEO of Airbyte. So Airbyte is an open source data integration platform. We've released the first version end of September. And since we've released it, we've had over 1,500 companies actually using Airbyte. So pretty good traction here. So before we dive into what the modern data stack looks like, I wanted to introduce you to a new paradigm for modern data team. So I think here we're all familiar with what ETL is: extract, transform, and load. So extract is really like pieces of code that can get data from a particular source. Transform is all the logic that is going to take that extracted data and transform it on the fly. So that's really, the transformation is really where you are injecting the business logic. So you want to make an analysis on something, you're going to put all the logic that is required for that analytics into the transform phase. And then once the data has been transformed, you load it so that your data analyst, data scientists can start using that transformed data. Unfortunately, like ETL is having a really hard time in the world today. First one, because ETL is very inflexible. There is a lot of friction when you want to change or update an existing pipeline. It is hard to add new data. Like, for example, if you've forgotten about a particular field, you will have to re-import all of the data so that you can actually have access to the data. So that creates a huge turnaround for data analysts or data engineer to actually get and get the insight that they want from the data. Also, with ETL, there is a lack of autonomy. So warehouses have made it very easy for less technical savvy people to actually consume data and extract information from it. And with ETL, these new roles are actually tied to engineers to modify the pipeline, to validate that the pipeline is still working. And the ETL product that exists today are also very complex. They generally require you to know about an internal DSL. They are very horizontal, meaning that they try to control everything in your data value chain. And this type of solution are pretty good at addressing 70% of what you need, but the 30 remaining one, today what we see is that most data teams are actually rebuilding their own data pipeline and data integration in parallel to a tool that they are paying for. So the new paradigm is extract, load, and transform. So extract and load, we try to push everything that is business related, every kind of bias that you want to put on the data as far as possible down the data value chain. So extract and load is really comprised of general purpose sources, general purpose destination connectors, and you just get the data to flow from one to the other, and you try to capture as much data as you can, and then you can apply your transformation. So by definition, because you have access to all of the data that was on the source at the destination, ELT is very flexible. You can update your model the way you want and pull the data that maybe you were not using in your past analysis, but it's there, it's sitting, so you might as well use it if it makes sense for your analysis. It allows many teams to be more autonomous. It is because now when you want to do a transformation, you don't need to talk to a data engineer. The transformation piece is actually much simpler. It is like SQL or it's DBT. So it empowers these new data savvy roles that are not too technical to do something with the data without the involvement of engineering. And also it's future-proof because all the data is being replicated. So you won't be missing anything. It's there. And so in the future, if you need to do a completely different analysis, you don't need to re-import all of the data. It's sitting on your warehouse or on your data lake. And the good thing about ELT is the source and the destination are general purpose connectors, meaning that they can work in any organization because there is no business logic as opposed to ETL. And that's why we created Airbyte. So Airbyte is really the starting point of the modern data stack. So Airbyte is composed of two main parts. So the first one is the connectors. So general purpose sources, general purpose destination that are contributed either by us or by the community. And these two communicate through a data exchange protocol. So make sure that the data has the right schema, it's properly serialized, and it can flow from the source to the destination. And on top of that, what we have is the core part of the project, which is really the scheduler, like the config and state management. And all of that is governed by an API and a UI. And Airbyte can actually run on a Kubernetes. It can run on like a native cloud instance and even on bare metal. So yeah, I mean, this is what like the high level view of Airbyte. So maybe we should just take a look and see a demo. That's all we're all here for, to see some demos. So let's get there. So this is a terminal. I assume you're familiar with it. And let's do a Docker Compose up. So obviously this could run on Kubernetes. So these are, all the different parts and components of Airbyte are actually starting, whether it's the server, the scheduler, and or like we're using a workflow manager behind the scene as well. So there you go. We can now connect to Airbyte. It started. So this is what you get when you first start with Airbyte. You can decide to receive updates from Airbyte. So let's just continue. So I'm going to show you an example of how we internally are using Airbyte in our data stack. So we're an open source project, so we do a lot of analytics on and produce a lot of analytics on the project. So let's see when we pull data from GitHub. So this is one of the sources that we support. We support around like 50 sources today, and our goal is to get to 200 by the end of the year. So let's add GitHub. There you go. We set up the source. So behind the scene, Airbyte is going to validate that all the credentials and configuration are correct. Now let's configure a destination where we want to push the data. So here I have a, you can see here I have a BigQuery. There you go. I set up the destination. Same thing, we test the connection first, and if you provide the wrong credentials, we don't let you move forward. And yeah, so now we have a source, we have a destination. What we want to do now is create the connection between the two. So this connection part is really about everything that is related to the data replication. So here, for example, we can say we want to replicate data every 6 hours, and we can select which object or which type of record we're interested in. So let's leave all of them here, and you can select how you want the data to be updated on the warehouse. So whether it's full refresh, whether it's incremental, if you want to get just append data, or if you want the data to be dedupe. So let's set up the connection. There you go. So this is what the UI or the control center looks like. So you have access to all the configured connection, so a source to a destination, or you can have a view by source or by destination. And you also have an admin section where you can see all the supported connectors. And if for any reason there is a change to a connector, like a contributor is adding a new model that was not supported in the past connector, if there is a change in the API, we publish new version of connectors, and you can just update, like typically here you can update to the latest. And yeah, so we can obviously see that the GitHub to BigQuery is running, and on BigQuery we can see the tables being created and data getting in. There you go. So this is the list of all the models that are coming in, and here, for example, you can see row assignee and maybe commits. Okay, so it's still running, so that's why the table are still empty. But yeah, let's not wait for it to sync. We have like a year of history of data being replicated. You can see it's working hard. So yeah, let's get back to the slides. And so now that we have a sense of how like data can be just imported easily into your warehouse, it actually goes to the next one, which is what is the open modern data stack. So what we know is no company has the same data need, and the problem with general purpose solution is that they will never address all of your need. Instead, the modern data stack is really a sequencing of the best tools, the best of breed, and like orchestrating that with something like an Airflow or a Dagster or Prefect. But it's really about selecting the best of breed based on what your organization needs. So for extract and load, you will have Airbyte, you can have Fivetran. That's not an open source project, but that is a product that does something similar to what Airbyte does. You have quality with great expectation, transformation with DBT or SQL. For BI, you can select the tool you want, whether it's a superset, a looker, observability with Monte Carlo. So observability is really trying to understand, is there something broken in my pipeline? Is my data fresh? Is the volume going down? So really about understanding and like making sure that you're working out of the right data. And of course, all of that is centered around the data warehouse, which become really the repository for all of your data, where all of your team can start working and get insight from and manipulating the data. And this modern data stack runs on on your clouds, on your public cloud, on Kubernetes, Docker, whichever makes the most sense for your organization. And so this is an example of one of our users and how they architected their stack. So they needed to replicate data from Salesforce, from Stripe, from Postgres, and a few other sources. So they've set up Airbyte on Kubernetes. They have Airflow on top of it that is basically sequencing how the data is being ingested and how it's being transformed. So we actually have a plugin for Airflow so that you can trigger Airbyte from Airflow. And yeah, so that's basically what you get. You have your data warehouse in the middle. They have a bunch of little DBT scripts that they sequence with each other. And on top of that, they've put Looker, and they also have another use case for this data is that when it's been merged, processed, modeled, they actually send that data back to Salesforce to enrich the data. So that's what we call reverse ETL. So today there are two main providers for that service, Hightouch and Census. So this is really a nice overview of what a modern stack looks like. And of course, based on your need, you might want to inject additional tool, like you want to have great expectation once the data has been loaded in your warehouse. You might want to use like Monte Carlo to verify and do the data observability on your data, but it's really composing your pipeline with a lot of building blocks and giving you like a system that is tuned for your use case and your organization. Yeah, so thank you very much for attending. You can find me on Twitter. This is my email, and of course we are an open source project, so we have a public Slack. You can connect. You can find me. My name is Michel. And yeah, so if you have any question, whether now or in the future, don't hesitate to reach out. Thank you very much.